Okay, so now that we've done our package work in Python, we're going to talk a little bit about dictionaries and how to use these effectively and kind of just their general structure. So you've probably heard about the idea of a dictionary. So building upon that knowledge, what do you think, which of the following is best suited for a dictionary instead of a list? Just take a moment. I think there are maybe two things people might choose here. I would suspect that A is going to be your most effective kind of data structure to organize as a dictionary. You'll see why in the next couple slides. Let's say that you're a bird watcher, okay, and you want to keep track of the number and each type of bird that you've seen. So not just what kind of bird it was, but also how many of that particular bird. You could use a structure called parallel lists. All that really is two lists that you combine, you kind of column bind them so that you can match up. Peregrine falcon, there's been one sighting. A harrier, there's been 5, and so on. The element of kinds, so notice that should actually be kind. Kinds here. Kinds corresponds to the count right here at the same place. So the ith component would correspond to the ith component. You just store these in two lists. So that's simple. All right, so let's take a look at an example of a parallel list and how we might set that up. So first we'd need to define a function which would add in a new sighting. So say you have a list of birds that you keep count of, and here's the kinds of birds you've seen. Then you've got the counts, how many times you've seen each of those birds, and then you've got the sighting here. All right, so this is just going to take in that list of strings, the list of integers, and the string, and give you nothing really back because it's just going to modify both of these lists, okay? So if citing not in kind, so notice we're using an if statement here with a negation because we're saying if the citing is not contained in kinds, then it's a new citing, right? So then we append that citing to kinds. So notice here's our object, our list, kinds. The function is append, and then we're taking citing and appending it to the end. Then we're going to take counts and append 0 to the end. Now the reason for that is because we have to know what is the indice for which we've added that place for the list for the new citing. So then we record what that indice is. So this takes the index, that's our function index, applies it to the list of kinds, our character string list, and says wherever that citing is, we want to record that index. So if it's in the, say, 5th place, then index here would be 5. Then it would know to go to the 5th place of count and increase it by 1. That's just a way to make sure that we get the right place for this. So let's take our list of 4 birds that we've seen so far and the number of occurrences or counts. Our new sighting, the sparrow, and then we're going to run that function, new citing on it. Once we do this, and you can just type through this and see the result, this list of lists here is just going to have all now 5 kinds that will end in sparrow, and then all 5 counts that will end in now 1. Okay, so that's how we do it using parallel lists, but we could use a dictionary instead. So let's take a look at a dictionary structure. Here we use a different way of declaring all the data. Notice instead of 2 lists, we're going to be declaring this new object called a dictionary. Instead of using square brackets, we use the curly brackets. That's just a syntactical detail here. And within that list structure, we can have multiple elements that we separate. The matching elements using this colon. So here we have peregrine. Remember the count for the number of peregrines we saw was 1. And then the Harrington falcon, we'll just call it falcon from now on, was 5. Red tail hawk was 2. Osprey was 11. So notice each of these occurrences within our dictionary is separated by a comma. So we just follow that syntactical recipe there to define our new dictionary. And so we're calling this quite reasonably bird dictionary. So now we can define yet a different kind of function for adding new sightings. But notice our inputs are different. Instead of having both list structures, the um, the counts and the kinds, and then the citing, we just have the bird dictionary and citing. So it's already a little more simple. Starting off with the same if statement, if citing's not in the bird dictionary, then we're going to create a place for that new citing, assign it a value of 0, and then increment it. So notice how much simpler this is. It automatically will update and add a new observation to the dictionary, which will be sparrow, and citing 1. So compared to parallel lists, there's only one dictionary, not the two lists. No call to index that might require a search of the whole list. You can imagine that might be computationally intensive, especially if this dictionary is managing something like a list of gene mutations that you might have thousands and thousands of gene mutations to search. That could become quite tedious and computationally intensive if you had to do it that way. So this dictionary structure might be a far better data structure for you in these kinds of cases.